Hello, my name is Jordan Casson, and in this video I will be going through the use of cutter compensation in Swood. Cutter compensation is used to compensate for things such as tool size, tool wear, and tool deflection. It allows the user to have the toolpath centered along the feature as opposed to the tool itself, therefore removing the need to manually offset the tool so its outer diameter is flush with the outer face of a pocket, for example. An advantage of using cutter compensation is it allows the user to interchange the tool for a given toolpath without having to reconfigure the toolpath to suit the new tool geometry. Instead, the offset from the cutter compensation is in the tool and therefore it will update when changed. It can also be used in a poorly calibrated machine to quickly recalibrate the tool position without having to reorganize any tools. Cutter compensation is off by default in pocket milling. This is because, due to the nature of a pocket, cutter compensation is not needed for the interior of the pocket and only needed for its outer bounds. Therefore, the toolpath generated for the pocket is blue, indicating that there is no cutter compensation. Users will usually apply cutter compensation when applying a wall pocket feature, as this feature focuses on the pocket's outer bounds and is therefore necessary in this scenario. It is common for users to combine a pocket and a wall pocket feature together, so it is represented as one machine operation, generating a toolpath cutting out the centre of the pocket as a roughing pass, then finishing the pocket using cutter compensation to ensure accuracy. This is a similar concept to when applying a contour feature. Cutter compensation is applied by default to a contour operation as it will need to ensure accuracy around the contour face. This is why you will usually see a green toolpath and a blue toolpath in a contour feature. The blue toolpath is the original position with cutter compensation not considered, and then the green toolpath is with cutter compensation, and therefore the distance between those two paths is the cutter compensation's offset. There is another operation available in Swood which used to be called pocket with compensation and is now called mortising. A standard pocket operation makes the resulting pocket size dependent on the size of the tool, and therefore a wall pocket operation is needed to finish the surface, removing the remaining geometry. With a mortising operation, however, the final size of the pocket is independent of the resulting pocket size. As seen in the right-hand diagram, if the tool size is reduced, the offset is adjusted to still meet flush with the outer bounds. Mortising is restricted, however, as it can only be used for standard geometry such as rectangles, circles, slots, and so on. If you need to pocket more complex geometry, then you will need to add the operations manually instead. Particular post-processors such as woodwop will allow the user to import the geometry and its coordinate location to the machine. This will let the machine calculate the toolpath itself. Standard operations rely on the user to program the X, Y, and Z locations and give the trajectories of the toolpath, and this is how we predominantly program toolpaths if using a different type of post-processor such as G-code. As there is no transition from computer to machine, there is no need for cutter compensation, as this will be calculated at the machine level instead. The disadvantage of this is that you cannot simulate the toolpath to double check it before sending it off. It is also worth bearing in mind that in some rare occurrences a machine will not allow for cutter compensation. If you do have this issue, please refer to our post team and they will be able to advise. Thank you for watching, and I hope you found this video useful.